All right, for this one, we're working with a histogram, which gives us a bend frequency distribution or a visualization of a bend frequency distribution. And then we're asked several questions, basically testing our ability to interpret the meaning of this bend frequency distribution. And so the first thing it asks is, does it seem like it's reasonable to assume that this was a survey of 500 recent college graduates? And if I look at this, I don't think that hits up, because this is my number of graduates per bin, right, or per class. And I have over 300 here and about 250 there. And so that's over 500 students just in those two bins, or in those two classes. And I mean, I've got lots more classes. I've got 5 more classes here that have students in them. So they're well over 500 students in this. So I'm definitely going to say false for 22. Okay, then it says more college graduate students had starting salaries in the $61,000 to $65,000 range than the $46,000 to $50,000 range. Well, to answer this, I want to take, the color that'll stand out against the blue and the gold there. Being erasers, I had to choose this problem. My 61 to 65,000 range, that's this class. And so what I'm really doing is I'm comparing the height of this class to the height of the 41 to 45,000 range. And the height of the 41 to 45,000 range is, 46. I misspoke, I misread. 46 to 50,000. 46 to 50,000 range. And so the height of this bin, and so which bin is taller? Well, the 46 to 50 bin is taller, so there's more students in the 46 to 50,000, which is exactly the opposite of this statement. And so again, this statement is false. This one, we have to do a little bit of math for. If the sample is truly representative, then for a group of 400 college graduates, we can expect about 28 of them to have starting salaries in the 41 to 45,000 range. And so let's erase what I've put on the graph so far. And so I'm interested in the $41 to $45,000 range here. And what I'm saying is, if this group were 400, how many are in the 41 to 45 class? To do that, you need to figure out, there's 2 different ways to conceptualize this that lead to the same math. I need to figure out how many, the way I like to think of it, is how many percent of my distribution is the 41 to 45 class. And so what I want to take is I want to take the frequency of the 41 to 45, and I want to divide that by the number of students that were surveyed. And that was a 45. Well, the frequency, if I'm going to estimate this, I'm going to estimate that at 75. So I'm going to estimate that at 75, and then divide that by, and I've got to estimate the height of each one of these. And so I'm going to estimate that at 140. So I got 75 plus 140 plus, I'm going to estimate that at 320. I'm going to estimate that at 275. I'm going to estimate this height at 125. This height is pretty well in line with that 50. And this height, if we try to draw a flat line all the way over, is going to be somewhere in the 20 to 25 range. So I'm going to guess 25. Okay. Now this will be the ratio of students that are in the 41 to 45 range divided by the entire population. All right, so let's find that number. I go to my calculator and I type in 75 divided by parentheses. I need the parentheses to keep everything in the denominator that I'm going to be adding together here. 140 plus 320 plus 275 plus 125 plus 50 plus 25. And I'm going to get some very small ratio, which makes sense because that column compared to the size of the rest of those columns is a relatively small percentage, a relatively small portion of my whole. Okay, and now I want to say if I had 400 in total, what I'm really looking for is how much of the 400 would be that ratio. And I'm going to do that by multiplying this by that 400. And so I'm going to take that answer and I'm going to do multiply by 400. And I'm going to get 29.7, approximately 29.7. And I'm going to say, you know what? We did not have exact numbers. I guessed a lot during the heights of those bars. And so 29.7 with all of the approximation that we did there, that's a pretty close approximation. And so I'm going to go ahead and say true here. Okay. Percentage of starting salaries falling above those shown by any rectangular bar is equal to the percentage of salaries falling below that bar. So it's saying that, if I erase all those marks, it's saying that if I select a bar here, I'll select this one. If I select this bar, that the percentage of starting salaries above and below that bar are equal. Well, I don't have to look too far to say that is much, much, much smaller than that, right? And so this is an absolutely false. There's nothing right about that because, I mean, I could even pick, if I wanted an even more absurd example, I could pick this bar, right? And so there's no salaries above that, and there's lots of salaries below that. And so that's definitely a false statement. All right. I hope that helps us with interpreting bin frequency distribution shown as histograms and even doing some approximation rough calculations based on those bin frequency distributions.